Good morning, students. Students, this lesson is of class 8th for the subject of physics, topic Ohm's law and factors affecting the resistance of a conductor, which is given in chapter 9, current electricity of your physics textbook titled Concise Physics by Selena Publications and is being submitted to you on 1st February 2021. All students may now open page number 197 in front of you. If all students are ready, then let us start with our first topic for today, that is Ohm's Law. Student, Ohm's Law states that current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided its temperature, the temperature of the conductor, remains constant. So what does this statement means? Students, it means that if we are having a conductor and we connect the ends of the conductor with a cell or a battery such that there are two terminals of a cell, a positive potential and a negative potential. So now what happens if the potential difference is supposed 2 volt? Let us suppose that potential difference given by the cell is 2 volts and current flowing in the conductor is 6 ampere. So now if we double the voltage, that means double means the double of 2 is 2 multiplied by 2, that is 4 volts. So if we doubled the voltage, the potential, then the current also becomes double. That means 12 ampere. Similarly, if you thrice tripled the voltage, that means 6 volt, then current will be 3 into 6, that is 18 amperes. Children, from here it can be seen that if you keep on increasing the potential difference, electric current also increases at the same rate. Let us suppose if we halved the voltage. Initial voltage was 2 volt. Now I have halved this voltage, that means 1 volt. Then the electric current would also be halved. That means the current flowing in the circuit becomes half of its initial voltage. So students, this thing can be written mathematically as potential difference applied across the ends of the conductor is directly proportional to electric current flowing through the conductor. But there is one condition, that is keeping the temperature of the conductor constant. And students, in physics, if we replace the sign of proportionality with is equal to, then we write down a constant here. Remember that whenever a sign of proportionality is changed into sign of is equal to, we will always write some constant, and in this case our constant is capital R, which means the resistance of the conductor. So let us continue further. Again, repeat the definition of statement of Ohm's law along with me. So it is current flowing through a conductor. The word conductor is very important here. Don't write current flowing through a body or current flowing through an object. Children, that object can be insulated also. It can be wood, glass, plastic sheet. So you have to be very specific. That is, current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided, what is the condition? Provided that its temperature is constant. This condition is also important to be written. So mathematically, we will write down V is proportional to I, or V is equal to Ri, where R is resistance provided to the flow of current by the conductor. Even if you arrange the formula of Ohm's law, you can find the value of R as R is equal to V upon I. And in case if you make subject as I, then listen what we are having here. V is equal to IR. So if we keep I on one side only, we'll be having V divided by R. Since R, if taken to the other side, will be coming in denominator. So I is equal to V by R. Similarly, you are having R is equal to, I will come to the left side, V divided by I. So students, as we have already learned last week, that resistance is a scalar quantity. It is not vector. Resistance is a scalar quantity and it is measured in ohms. The SI unit of resistance is ohms. Now, using Ohm's law, let us learn to define the SI unit of resistance. Let us write down the definition of the SI unit of resistance. For writing so, we will use the formula R is equal to V divided by I, and instead of R, we will write down 1 ohms. Instead of V, we will write 1 volt, and instead of I'll write down 1 ampere. So we have replaced all the physical quantities with their SI unit. Now, what is 1 ohm? It is equal to 1 volt divided by 1 ampere. This is mathematical relation. Now let us formulate the definition of 1 ohm. So children, the resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when the potential difference across its ends is 1 volt. So what is 1 ohm? 1 ohm is the resistance given by the conductor when a current of 1 ampere flows through the conductor when the potential difference of 1 volt is applied across the ends of the conductor. So this definition of 1 ohm is very important. Now, coming further, we will study today factors affecting the resistance of a conductor. Students, resistance of a conductor depends on various factors. So we will study each factor in detail. Now the first factor for today is the length of wire. Students, if length of a wire or conductor increases, the resistance offered by it to the flow of current through it also increases. This is because the number of collisions suffered by the moving electrons will be more if they have to travel a longer distance in a wire. Now students, suppose we are having a wire of length 1 meter and we are having one more wire of length 2 meter, and we are having one electron which has to go from one end to the other end of the conductor. In case of wire A, the first wire, the electron, the charge has to travel a distance of 1 meter to reach the other end. So students, the electron will be colliding with the positive ions and then it will reach to the other end. The same happen in wire number 2 or wire B. In wire B, again, the electron has to go from one end to another end. But now it has to travel a distance of 2 meters. And there will be more positive ions in this case, such that the electron will be colliding more particles. It will be suffering more collisions. If number of collisions are more, the resistance offered is also more. So children, it means that a long wire offers less resistance than a long wire will offer more resistance. It will offer more resistance than a short wire. So it can be said that resistance is directly proportional to length of the conductor. Now coming to the second factor, that is area of cross section of a wire. It means more area or less area of the wire. Children, basically the area of the wire will determine the thickness or thinness of the wire. In a thick wire, electrons get a large area of cross-section to flow as compared to a thin wire. What does it mean? That if we are having a thinner wire and a thicker wire. Now children, the electron in case of a thin wire is not having ample amount of space and will be doing more collisions. Just imagine a very narrow road or a street. There are more chances of a person colliding to the other if the passage is narrow. But if the passage is broader or if the wire is thick, now this electron is having ample amount of space to travel from one end to another end. So it will suffer less collisions. Since there is much space, so chances are that it will suffer less collisions. Less collisions means less resistance. Thus, we will say that in a thick wire will offer a less resistance, while a thin wire will offer a high value of resistance, and thus it can be said that resistance is inversely proportional to area of the wire or conductor. Coming to the third factor, that is the temperature of the wire. Students, if the temperature of wire increases due to heat, ions in it vibrate more violently. The electrons and the positive ions all will be vibrating because the temperature has risen, and because of high temperature there is heat in the conductor. And as you have already learned in your lower class, that heat causes vibration of the molecules. Now, as a result, the number of collisions increases and hence the resistance of wire increases. Thus, resistance of a wire is directly proportional to the increase in the temperature of the wire. The last factor is the material or nature of wire. In different materials, the concentration of electrons. Students, concentration of electrons means number of electrons. So in different materials, the number of electrons and the arrangement of atoms are different. Therefore, the resistance of wires of same length and same area of cross-section, but of different materials, differ depending on their material. For example, children, if I am having a wire of copper and the other wire is of aluminium, suppose both the wire are of same length and same area, still the resistance is different. Why? Because one is of copper and the other is of aluminium. So the material is different. Both are good conductors, but copper is a good conductor as compared to aluminium. So aluminium will offer more resistance. Therefore, the resistance also depends on the material of wire. Good conductors like silver and copper, which are having higher concentration of free electrons, offer less resistance. Now, children, we will do one more topic, that is flow of charges, which constitutes current. Now, children, as done in class 7, if two bodies at different temperatures are kept in contact, heat flows from a body at high temperature and it flows till both the bodies attain the same temperature. So in the case shown on page number 3, I have taken two conductors A and B. Conductor A is kept at 70 degrees Celsius while conductor B is kept at 30 degrees Celsius. So the heat will flow from A to B. The direction of flow of heat is from conductor A to conductor B, and it will flow till both conductors are at same temperature. Children, similarly, if we join two charged conductors, the electrons flow from a conductor having more electrons to the conductor having less or no electrons. So the electrons will flow from more number of electrons to less number of electrons, which can also be said as the electrons are flowing from higher concentration to lower concentration. The movement of electrons stops only when the number of electrons in both the conductors becomes equal. Now, children, see the diagram where a conductor A having positive charge on it is connected with the metallic wire with the conductor B, which is neutral. Children, an atom having a neutral sign on it, while the other is deficit of electrons. Positive charge means that it has given its charge, that it has lost its charges. So it means that A is having less charge since it has already given, while B is having more charge. More electrons are in B. So now the electrons will flow from B to A. The electrons will flow from B conductor to A till both attains same charges. Children, the thing to understand is that both charges are connected with a metallic wire. The connection between the two spheres should be with the conductor. If this wire is insulating, if this wire is made up of any insulator, then there will be no flow of electrons. Coming to the second case, the electrons are distributed in a manner that sphere A is having negative charge on it, while sphere B is neutral. Now students, how does an atom becomes negative charged? When it attains some electrons, when it gains some electrons. Now gains mean it is having more electron. It has already taken more electrons. While B is having less electrons. Now the direction of flow of electron is from high to low. So that means current electrons will flow from sphere A to sphere B. And the third case. In third case, now the electrons are arranged in a manner that sphere A is having positive charge. That means it has lost some electrons and therefore it is having less charge. While sphere B is having negative charge. That means it is having more electrons. So the flow of electrons in this case will be again from higher number of electrons to lower number of electrons. That is from B to A as shown in the diagram. Again children, the note is if the charged conductors are joined by an insulator, then there will be no flow of electric current as insulator do not allow flow of electrons through them. The moving electrons constitute an electric current and the direction of electric current is taken opposite to the direction of flow of electrons. While current always flow from high potential, that is positive end, to low potential, that is negative end of electric cell or battery. And for the continuous flow of electric current, it is necessary to maintain an excess of electrons on one conductor. On one conductor, there should be more electrons and deficit of electrons on the other conductor. So one conductor should have more electrons. The other conductor should have less electrons. Only then the electrons will flow and hence the electric current will flow continuously. And this maintaining of difference in electrons is done by an electric cell or a battery. Children, we have already learned that current is defined as rate of flow of charge, that is amount of charge flowing in 1 second, and it is measured in the unit ampere, which is written as capital A. Children, with this I come to an end of today's interactive session. You all are requested to do the tick marked exercise question in your physics notebook. See exercise 9b, question number 1. You have to state the direction of flow of electrons and flow of current. Electrons will flow from high number of charges to low number of charge. So minus means it has gained electron. So electrons will flow from A to B. Current flows from high potential to low potential. 10 volt and 5 volt. So current will flow from high potential of 10 volt to low potential of 5 volt. And then you have to do question number 3, which can already be done as we have done it earlier also. V is equal to work done per unit charge. Question number 6, question number 12, 13, 14 can be done very easily. And then students, there are 4 numericals on which we will be using only 2 formulas. V is equal to work done per unit charge, where work is measured in joules. If we write down V is equal to W upon Q, W means work done, which is measured in joules. Q stands for charge, measured in coulombs. And V is volt. And one more formula, that is Ohm's law. V is equal to I into R. I is measured in amperes. R is measured in ohms. The symbol of ohms is written here. So using these 2 formulas, you have to do all these 4 numericals. Thank you, children.